our next speaker is Mehta, and Alid is a security consultant in the cloud security team at WithSecure, where he spends the majority of his time exploring Microsoft cloud services. And in this talk, he'll explore service tags in Azure with an aim to highlight several novel methods by which attackers can get access to a corporate environment from their usage. The title of his talk is Tag, You're Exposed, exploring Azure Service Tags and their impact on your security boundary. Please welcome Alid.
Thank you very much. Thank you very much. Thank you everyone for being here today. I appreciate it. It's fairly early on a Sunday morning, so I appreciate that, and thanks to all the Cloud Village guys for putting this on. I've got quite a lot to go through today, so I'm going to jump straight into it. As he explained, I'm going to be talking about Azure Service Tags. We're going to go through the impact they might have on your security boundary and where those lines might be a little bit blurred. Before we jump into it, just give a brief introduction to myself. So I'm Alid Mehta. As you said, I'm one of the security consultants at WithSecure, mostly work in the Azure space at the moment, but a bunch of Windows stuff as well keeps me quite interested. Got my Twitter and my GitHub handle at the bottom there for any of the cool projects I'm working on, or if you want to have some discussions about anything after this. So yeah, at WithSecure, based in our Manchester office in the UK, and you might have seen there was another name on this talk as my partner in crime, Chris Philipov. So Christian's one of our senior security consultants. There's his Twitter handle at the bottom there. Unfortunately, he couldn't make it today, but he supported a bunch of this research, so bit of love to your boy Crispy. So, just a high-level agenda of what we're going to be talking about. Going to go through what my goals with this research were. Service tags are a fairly simple concept, so I could have fairly high-level research goals here. Give you an overview of what service tags actually are, how they work, a bit around the anatomy of a service tag. And then we're going to have a look at 3 specific examples of tags. We're going to have a look at Azure Cloud, Logic Apps, and Azure DevOps to get an idea of kind of how they can be exploited and how we can defend against that as well. So, what were my research goals here? As I said, fairly simple concept, service tags, but to start off with, I needed to understand what do they do? How do they work under the hood? What are they actually functionally doing there? And from that, we'll be able to understand how they're used. And we want to understand this from 2 perspectives, right? Is how Microsoft recommend they're used and how organizations actually use them in practice, because those 2 things don't always line up. From there, as an attacker, I want to understand how these can be abused, how we can use this to maybe get access to resources that have been exposed in a manner that the implementer might not have intended. And from the flip side, what's the alternative, right? What can we do to protect ourselves in these kind of deployments? What other controls are available? What architectural decisions do we need to make so we're not falling into these little pitfalls here? So hopefully that will shed some light on what service tags are and we should be able to get an understanding of the security impact of them. And so, what is a service tag? Let's have a nice little definition from Microsoft to start off with. A service tag represents a group of IP address prefixes from a given Azure service. So what does that actually mean? Basically, this is a managed set of IP ranges that Microsoft manages on behalf of their customers. And these services, these IP ranges correlate to either ingress or egress IP ranges for Azure services. The idea here is, as we've shifted a bunch of things to the cloud, a number of controls have been abstracted away from us, and implementing secure kind of inter-service communication becomes a bit more complicated than it would have been on-premise. So one of these abstractions is presented to us through service tags. And as suggested, they're to be used within network controls. There's a few different places we can use them. Most common is network security groups. So these can be attached to kind of subnets or network interfaces to provide kind of ingress and egress network security rules. Can be used in Azure firewalls. Slight caveat to that, which I'll touch on a little bit later, is they can only be used as destination addresses within Azure firewall rules. User-defined routes. A common use case might be for this if we want all traffic going to the Azure storage service to go through a certain network appliance to provide some additional scanning or something along those lines. There's an API exposed that we can consume these through, so you can integrate it in kind of any of your network stack, whether that be on-prem, whether that be some custom tooling that you have. So that gives us quite a lot of flexibility to consume this. And it's also exposed through kind of just a downloadable JSON file, which gives us a point-in-time kind of list of these service tags. Here's an example of a fairly common use case. So this comes from the Microsoft documentation as a recommended use case of service tags. So we see here we've got a network security group. That network security group has denied all outbound traffic, but with some exclusions on top of that. So that means that any resource that has that network security group attached would only be able to access Azure storage resources or specifically SQL resources in the East US region. We'll touch on kind of the regional breakdown a little bit in a moment. But that's essentially what a service tag is. Let's have a little bit of a look into like the anatomy of the service tag and what a definition of a service tag looks like. We use an adjacent example here just because it's the easiest to visualize. But here we've got kind of a service tag for a logic app. So we've got the name and the ID there, nice and easy, represent the logic app. Got a change number in the properties. That's just so you can track any kind of iterations through it. But we don't have to worry about that for context of this. We've got some regional breakdowns, touch on those in a moment, but at the bottom, we've got the meat of the tag. So what these are essentially are public IP address ranges that represent either the ingress or egress traffic from logic apps, right? We've actually got different types of service tags that we can use. So 15 of the tags can be used to represent inbound traffic from Azure services into your environment. 40 can represent traffic from your environment out to these Azure services, and we've got 35 tags that support both, leaving us a total of 90 tags. For the context of this, we're going to be focusing particularly on the inbound tags, but certainly there is further research that can be done on the outbound perspective, and there'll be some cool kind of data exfiltration opportunities there. One of the key things about service tags is whether it's me downloading the service tag or you downloading the service tag, the IP ranges are exactly the same, right? These IP ranges represent the service as a whole. They're not representing a specific organization's consumption of a service. Slight kind of caveat to that is, as I'm sure many of you are aware, if you've done much with Azure, we've got a few different kind of Azure deployments or environments, right? We've got the Azure public cloud, which the majority of customers are using, but then we do have the US government, we've got Germany, and we've got the China 21 via net one as well. So I just wanted to make the point that we've kind of got 4 definitions of different service tags, but the majority of people will be in the Azure cloud one, the standard public cloud, and so the definitions that we're getting in service tags are going to be exactly the same. And that's really where this talk has come from and this research has come from, is the fact that these service tags by design include other organizations' environments because they just represent the service as a whole. Just want to touch quickly on service tag relationships because we've got the concept of like supersets and subsets here as well. I mentioned a couple of times that we've got regional tags. So if we look at a tag here, we've got logic apps UK South. So this represents the logic app service specifically within the UK South region, right? But you'll notice we've got the IP address ranges here. I've just picked 3 examples. You'll notice they're /32, so they're only a single address, but that's just because they're the top examples in this list. So the same concept applies however big the range is. Well, what we'll notice as well is each of these tags exists within the logic app service tag as well, right? So each service tag has a regional breakdown as well, is kind of the point I'm trying to make clear here. But we can actually go another step further to that, and we've got the Azure Cloud Service Tag. So we can see that these IP address ranges are covered by that /17 there. And the point here is the Azure Cloud Service Tag is all-encompassing, right? It covers everything within the Azure public IP range. There is another breakdown to this as well. We've got the Azure Cloud Regional one too. So for each service, we've got region-specific and service-specific. Then we've got service-specific, and we've got region-specific, and then we've got Azure Cloud as a whole. So that Azure Cloud includes everything in the Azure public cloud. Compute resources is an interesting one. So not necessarily all services have a dedicated service tag with them. In the previous example, we were looking at logic apps. They've got a tag allocated to them. Compute resources, on the other hand, if we've got a VM here, this is just a VM deployed in Azure, grab the public IP, and we find that it only sits within the regional Azure Cloud tag and the Azure Cloud tag, right? There is no dedicated one for virtual machines. So this comes with quite a nice, easy to understand attack vector, right? So let's have a look specifically at the Azure Cloud tag. One little example environment that we're targeting. So we've got a target organization here. We've got Azure subscription deployed. Within that, they've got a virtual machine here. So we're using CouchDB as the example. Just to make it clear, there's nothing specific about CouchDB that makes it exploitable in this manner. I just needed a nice REST API to be able to interact with for testing. But the network interface for that virtual machine has a network security group associated. And we can see the rule set here, right? So we're allowing all traffic from the Azure Cloud Service Tag. To be clear, the service tags only kind of correlate to the IP addresses, so we need to set any ports, etc. Separately. In this instance, we're just allowing all ports. These two rules here are just default rules. This would work exactly the same manner without them there. And crucially, we've got that deny all inbound at the bottom, which is the default for all inbound NSGs. So if an attacker went to try and access that resource directly, they're going to be blocked by that network security group, right? They're connecting from the public internet. They're not satisfying that Azure Cloud Service Tag inbound rule, so they're going to be blocked. But as you may remember from the previous slide, all virtual machines are covered by the Azure Cloud Service Tag, and there's nothing specifically tying that to an organization. So an attacker could just deploy a virtual machine in their own environment, and they can use that to access your resources, right? That's going to satisfy all the requirements for the Azure Cloud Service Tag, because you're falling within that address space. One thing I do want to make clear is we're talking purely about network access for the context of this, right? That attacker would have to have otherwise compromised credentials, etc. Service tags, we're talking purely from a network access. Another thing to be clear about is these two environments are completely independent, right? So that's target organization has its own entry ID tenant associated with it, and the attacker organization equally, their own individual entry ID tenant, their own individual subscription. There's no correlation directly between them. Now, I want to talk about something not technically a service tag, but very related, and we see this a lot in like live environments. That's the concept of this allow Azure services. You may well be familiar with this little checkbox here. So this is a screenshot from Azure SQL instance. So this little checkbox is an exception which says, allow Azure services and resources to access this server. And what does that mean? It's essentially the Azure Cloud Service Tag. And what is particularly interesting about this is, even if you have all your kind of IP allow lists set within there, this exception is still going to take effect. In my opinion, all those IP allow lists are pretty redundant if you're then allowing anything from the Azure cloud, because we could do, as you saw in the previous slide, just deploy a VM in Azure and either interact with the resource through that VM, or we could even do something like set up an open VPN server on that VM and then we can access it from anywhere. This actually exists for multiple different database services, and thankfully they word it differently in every case to make it nice and easy to understand. So this one's for Cosmos DB, and it's actually a lot clearer, the impact from this one. It's allowing connections from within Azure public data centers. So you can understand the impact of that one a lot more clearly, but the functional kind of impact of both of them is identical, just worded differently. And this is always quite a hard one to explain, because these organizations, you'll see it and be like, well, I've got these lists of IPs that I'm permitting, but they don't understand the implications of having that checkbox set as well. Now, up to this point, with the virtual machines, we've got a lot of flexibility, right? We can just run any arbitrary code on there. As I suggested, we could set up a VPN server, and then we can run any payload through that we like. But what about some of the other services? So for those of you who don't know, Logic Apps is a service from Microsoft for low to no code kind of workflow automation. So the way it typically works is you have a bunch of triggers set up. So that can either be kind of a webhook, or it can be integrating with kind of some of the Microsoft stack. And then from there, you're calling connectors, which are typically REST APIs. You can get a bit more flexible with that. You can write some JavaScript connectors, etc. But typically, you're just calling a REST API with it. So let's have a look at a very similar environment. Again, we've got CouchDB deployed, but this time you'll notice that the NSG rule is allowing inbound traffic from the Logic Apps tag instead. Again, we've got this default deny, all inbound at the bottom, and we've got those default rules there, which have no impact on this attack. So an attacker trying to access the resource directly, they're going to be blocked by that NSG. They're not satisfying the rules of that for that Logic Apps service tag. But very similarly to how we were seeing before, they could just deploy a Logic App in their own environment and use that to interact with your services. So I decided to kind of make a flexible way of doing this, I thought you could write a logic app that is dedicated to that specific endpoint where you're calling it, and then you're quite restricted in kind of how you're interacting with that service, and if you want to change the service, you need to develop a new logic app, etc. So I just built a nice little HTTP relay. So HTTP trigger on here. Annoyingly, one of the limitations of logic apps is you can't have it supporting multiple different methods, so this was set up as a post method. And then we just passed a bunch of queries and parameters. What I did in this instance was I used just a few headers to determine what the upstream target API that I wanted to hit was. So we got the URI, the method, and because there was a conflict with using the authorization header with the logic app directly, because it expects you to have that, this allows you to kind of pass any upstream authorization that you need there as well. Nice and simple, calls the target API. And crucially, this calling the target API is going to egress from the public IP addresses associated with logic apps, right? So the public IP addresses that are covered by that service tag, so therefore that traffic's going to be permitted. And then simply just return the API response to the caller. So having a little look of how that would actually look. We've got that authorization header I mentioned earlier. As I've said a couple of times, we're talking purely from a network perspective, so we're on the assumption that we've got some leaked credentials here. Here we've specified the endpoint that we're going to call, so that's the logic app that we've just set up as an attacker, and we're just going to curl that. As I mentioned, we're going to have to do it as a post request. We set the specific method that we want to use for the upstream server there, and we're going to just call the endpoint to list out the databases on that CouchDB instance, and thankfully, that all works. We can grab the product catalog there, which is one of the databases, and you can interact with this however you see fit, based on whatever level of access you have with those credentials. So that was pretty cool. We've now been able to establish a way that the attacker can interact with the service wherever they need to from. So the attacker controls that logic app, so they control all the authorizations to that logic app, they control what kind of network locations that logic app can be called from. But getting in some of the other services, we need to get a little bit more nuanced with it. For in the initial scenario with Azure Cloud, we can just deploy a VM, run arbitrary code. But logic apps, we've still got a decent bit of flexibility with being able to create our own workflows, be able to generate our own custom HTTP requests there. But Azure DevOps is a little bit different. So for those of you who aren't familiar with it, Azure DevOps is kind of a suite of products available from Microsoft with a bunch of different DevOps tools available for you. So some of the cool ones are the repository capabilities, so you can store your source code in there, whether that be application code, infrastructure as code, etc. You've got Azure Pipelines. So Azure Pipelines are for being able to run your CI/CD tasks, run your application or infrastructure deployments, etc. And then we've got a bunch of other associated stuff like work items, issue tracking, Kanban boards, all of that nice stuff. But one of the key things I want to point out for anyone who is familiar with DevOps and might have jumped to this conclusion already, unfortunately, the Microsoft hosted runners for pipelines are not covered by the Azure DevOps service tag, so we can't just use that for kind of running arbitrary code there. Those are just covered by the standard compute node, so they're covered just by the Azure Cloud tag. So from that perspective, we now need to look at how we're abusing service functionality and what features it gives us within the control plane there to be able to interact with these services, and what kind of integrations are natively available that we can look to abuse. So there were 4 different angles that, as I was looking through, I kind of thought worth exploring. We've got the data import from SQL, we've got service hooks, we've got Git repositories, and we've got the pipelines. So data import from SQL, purpose of this is essentially if you've got the DevOps on-prem server and you want to migrate to DevOps Cloud, this provides the mechanism for doing so. And it stages it through Azure SQL Server and allows you to make that migration there. But if we have a look at this little diagram here of how the migration flow should work and how it's going to block us, we get a bit of a better idea. So the way the process works at a high level, cutting out a bit of the steps, but not really relevant for here, we've got this migration VM. That needs to run a certain tool to generate a migration manifest. That manifest can then be passed to the Azure DevOps Cloud instance to initiate the transfer. One of the crucial issues there, though, is that VM running the migration tool needs direct network connectivity to that on-prem, well, to that DevOps server instance to be able to generate that manifest. And it does have some integrity checking in there, which I haven't been able to get around. So for an attacker, we can't initiate that we can't generate a valid manifest file because we do not have connectivity from a VM to that DevOps server. So that kind of scrapped that idea. There may well be further research available there, so I'd encourage anyone, if they want to look into it, that might be viable, but I couldn't find a cool method for it. So that takes us to service hooks. So what are service hooks? Basically, they're event-based webhooks that you configure in Azure DevOps. These events can be a variety of different things, whether that be kind of a work item being updated, changes to code repositories, changes to releases, things like that. The issue here, though, is we've got very limited control around the schema of the message that is sent and the content of the message. So here's a little example here for a release abandoned, right? I have cut out a couple of the properties here for brevity, but the point's still valid here. We can't control what properties are sent in this service hook, right? This is automatically generated for us. All we do is decide what event is triggering it. We would have a little bit of control of certain properties here, like we can name the release, so we can have that resource name value set. But the functionally being able to exploit this to target something, you're very restricted in your schema. You might be able to use it to kind of enumerate valid services or something like that and valid endpoints, but limited attack viability. Again, maybe worth exploring further, but I kind of left that one be in hope of something more interesting. And that led us to Git repository and Azure pipelines. So those ones were way more fruitful, so we'll jump into those in a little bit more detail. Before we'll have a look at the environment we're kind of looking to target here. So we've got a target organization, and here we've got a virtual machine with a GitHub Enterprise server deployment in it. And this is actually GitHub Enterprise for a specific reason. A lot of these capabilities do only work with GitHub Enterprise. There are certain features which will work with just a generic Git or SVN server. I think there are certain ones that work with Bitbucket as well, but I couldn't get a trial license for it, so didn't play with that one. And the way this organization is using it is they've got their code repository stored in GitHub Enterprise, they're using Azure DevOps to run pipelines, and they've got a run of VM here. So that's running all the tasks that the pipeline generates. Crucially, you'll notice that all of these components need to be able to communicate with each other, right? The communication here needs to be there so that you can trigger the pipelines. DevOps needs to be able to send the task to the VM, and then the VM needs to be able to speak to GitHub Enterprise to be able to pull the code repository to do any build or any integration tasks there. An attacker won't be able to access that directly, so they need to look at ways that they can deploy Azure DevOps within their own environment and use that to pivot in. So one of the key kind of use cases I mentioned that Azure DevOps supports is storing your code repositories in there. This can be done in the standard way of create a repository and then commit and push some changes to that repository. Nice and easy. But one of the other functions that it supports is the ability to import repositories. And thankfully, these import tasks are initiated from public IP covered by the Azure DevOps Service Tag. So if we look at this little screen capture here, we've got an attacker within their own environment. They simply go to import the repository, put in the URI of that repo, and chuck in the PAT token. As I mentioned, we're talking purely network perspectives. They would have had to compromise credentials otherwise. And we can see that they've got access to this code repository here. They can navigate through and obviously find all the secrets that haven't been hard-coded in there, because that never happens. But you get a couple cool things with this. A couple cool things I want to point out. Because we're importing the repository here, we actually get all the commit history as well. And again, quite a lot of time, if these secrets do get hard-coded and people discover them, they'll take them out, recommit, forget about the fact it's in all their commit history. So that's pretty cool there as well. But crucially, we're getting a point-in-time copy here, right? We'll have to reinitiate another import if we want to get any kind of updates to it. And we're not allowed to push any changes back to the core repository here. We've just pulled them. So how can we take this a little bit further? How can we get a bit more interesting? One of the other use cases I mentioned was having your code stored elsewhere and just using Azure DevOps for the pipelines, right? So DevOps needs some way of understanding what that code is, being able to manage that pipeline there. So we have the concept of source providers. Let's just set up a source provider quickly. And this is in the attacker's environment. Go to GitHub Enterprise. And crucially, you'll notice here that I'm putting in the root URI of the GitHub Enterprise server. I don't have to specify a specific repository as I needed to earlier. But what does this source provider actually give us? One nice thing to start off with is there's an API we can use to interact with it. So it's just a little screenshot of the Microsoft documentation. You'll notice down the bottom, we've got listing repositories and listing branches of those repositories. But more interestingly, at the top, we've got getting file contents, getting path contents, and getting pull requests. So that's pretty cool. Let's call some of those APIs here. So, a couple things to note about this request here. You'll notice we're doing authenticating with the endpoint. Crucially, this is the path of the attacker's DevOps instance because they're calling the API through their DevOps. We've got to specify the service endpoint, and that's just the ID of the service integration we created in the previous slide. And here we can just call that API. So this is the organization name and the project name of the attacker's environment that they've set up this integration in. And we can call this repositories function. Nice and easy. We get a JSON back with an array of the repositories. Awesome. One of the key things I want to point out here is the attacker can call this API from anywhere now, right? They're calling the API of their DevOps instance, and that's then going away and calling GitHub Enterprise. So they now expose this resource to anywhere they see fit. And we can take this a step further. So let's look at enumerating the path contents. So here we've specified a repository. That was the corp user bot that we saw in the previous slide. And we've updated the request here to check the path contents. We're just doing the root of the repository. We could specify a specific subfolder or something we want to look in, but response here, we can see it's got README file in. We get an array of all the files within there. Take that one step further, and we can have a look at the file contents. So here you can see I've set a path. I think the example I used was just a Microsoft Graph Node.js app or something like that. So here we're just grabbing the tsconfig file. You can see we're using the file contents. And we get the content of the file here, which is great. Attacker can call this from any time, and they're getting a live file now, right? Whenever they call this is going away and calling GitHub and getting that content for them. You can also do a bunch of cool stuff like pull requests, things like that as well. But can we take that even further and look at Azure pipelines? So let's look at an attacker in their environment setting up a pipeline using that service integration that we just saw a moment ago. So they'll go to create the pipeline, GitHub Enterprise, select that integration we created a moment ago, and crucially you see we get a list of repos here. That's calling that API we saw a moment ago to list of repositories, so we can select any repo. And if you've created a pipeline before, you might be a bit confused, because normally you get a prompt of what template you want to use. That's because we're not creating a new pipeline. There's already an existing pipeline in there, and we're now modifying it. So we've got the build tasks of the target organization's pipeline, so as an attacker we can just go in and add something in there. In this example, we're just calling an endpoint that we control with a couple of query parameters. So it's a little bit small, you probably can't see it, but it's just who am I and host name. So we're going to save that. You'll notice I am committing directly to the main branch, which hopefully you won't be able to do. So you probably have a couple of other challenges of working out how to kind of satisfy the any branch protection, any commit approval processes. We're talking purely from a network perspective here. And you'll notice I saved that instead of run and save, because our pipeline runners aren't going to be able to hit that GitHub Enterprise instance, so they're just going to fail immediately. But what we should see, if we get that VM that endpoint was, that I put in the task, listen on port 80, and we should see after a few moments that we're getting a callback from that runner with the name of the account being used and the host name of the device that was running it. So we've now just kind of got arbitrary code execution on that pipeline runner. So we can do a bunch of stuff here, either messing with any kind of infrastructure, we can look at stealing some secrets. We've got a lot of control here. I haven't found a method to be able to modify any other files yet, but I'm sure there is one. So I welcome any collaboration or kind of further research in this space. But what can we do about it? I mean, fundamentally, it's working as designed. Like, these are what service tags do. These are what service tags are meant to do. So I think the key thing here is just the education around it and understanding what the potential impact of it is. But there's a couple of other controls that we can look to get in place and re-architecting certain components of our network. So private endpoints, as the name suggests, allows us to bring a resource into a private network, so we can just have our communications going across that VNet or that subnet, and we don't have to deal with any public IP addresses coming in. That won't work for every service. Some things, like a lot of our app services, we need to look at instead using VNet integration to allow them to egress traffic into those environments. Ultimately, my suggestion is don't use service tags unless you absolutely need to. Understand the risks around them. 90% of the time, private endpoints or VNet integration is going to make your life way easier, and you're not going to be leaving yourself with this kind of overly exposed situation. The labs for this will be available at the end of the conference on the WithSecure lab, so you can play with any of these kind of scenarios. They're not quite ready yet, but they should be there in the next couple of days. And that is it. So I think we're probably tight on time. So yeah, if anyone's got any questions, feel free. Or catch me afterwards and we can... Hello.
Hi. So like a lot of Vault solutions, even open source Vault, have dynamic credentials, especially for Azure Service Account Principles, stuff like that. What do you think about the application using its cloud identity at startup, at runtime, to get those temporary credentials and then using those for all interactions?
Oh no, I definitely think that's valid, and using managed identities and things like that where possible is definitely a good approach. I think the question was around whether resources should be grabbing these kind of credentials at runtime and dynamically, right? For the service tags, we're talking purely about network access. So yeah, I fully agree with that. And we should be leveraging kind of key management solutions or managed identities to manage those credentials for us, in conjunction with not using service tags probably, and re-architecting your environment accordingly.
Thank you.